take 5 minutes or so to go over Monday's notes, and then we're going to move on to today's notes.
Okay, okay.
You bet. Okay, so Monday's notes, let me grab those. We started off by talking about Pythagorean theorem. Most of you have seen Pythagorean theorem before. Let me focus that a little bit better. Pythagorean theorem only works for a right triangle. It has a special relationship between the sides. And a right triangle, we will call these two sides that join the right angle, we'll call them legs. And the slanted side we'll call the hypotenuse. So when you look at it in the formula, it's going to look like A, B, and C. It does not matter which one you call A or B, but it does matter which one you call C. C is always the longest length, and it's always directly across from the right angle. So if you're ever unsure which one is C, just like draw a little arrow right across from the right angle, and that's the one. So the relationship that it has is A squared plus B squared equals C squared. So when we're solving for the missing variable, we'll write them in. 3 squared plus 4 squared equals C squared. And remember, squared is a number times itself. So 3 squared, 9 plus 16 equals C squared. Excuse me. To undo a square, remember from your algebra days, is a square root. And a square root of 25 is 5. Technically, it's also negative 5, but we're going to use the positive value because it represents a length. Okay, so on this one, we have sides A, 5, and 13. Remember that the C is always on the right side. So when you square everything and start to solve, so you have A squared plus 25 equals 169. Subtracting the 25, you get A squared equals 144. Taking the square root of both sides, you get A equals 12. Okay, so very straightforward, just an algebraic equation to solve. Okay, the second page was just going over a few more examples because they involve square roots. So if both sides are 7 squared and 7 squared, 49 and 49 equals 98. So 98 equals C squared, square rooting both sides. Okay, so here's where we get last week's information. Okay, so I need to break down 98. So I see that it's an even number. Because honestly, I don't remember what numbers may go into 98, but I know 2 goes into 98 because it's an even number. So I go 2 times 49, and lo and behold, square root of 49 is 7. So I bring out the 7, I have a leftover 2, which becomes my answer. Okay. And then another example. If you have sides 4 and 4 root 3, here's the tricky part that some students forget. When you have a 4 root 3, you need to put it in parentheses because if you remember from your algebra days, that square affects both of those terms. So we have to square the 4 and the root 3. So this one over here will give me 16. 4 squared will give me 16 times, there's an invisible times there, root 3 squared. Well, remember the square and the square root, they cancel each other, so I'm just left with 3. Or if you want the long way around it, it gives you root 9, and square root of 9 is 3. So we add those together, we get 48 and 64. Square root of 64 is 8. So that C was 8. And last example for Pythagorean theorem. Okay, C is 14, one of my legs is 5. So I've got A squared plus 25 equals 196. Subtracting 25, we get 171. And here's where some people stop. I do not want a decimal. I will not give you credit for decimal unless I've said specifically to give me a decimal, which is rare, really rare. So now I need to start looking at my divisibility rules because there's no way I know what goes into 171. So I add up my numbers. I know 2 doesn't go in because it's not even. So I add 7 plus 1 plus 1, I get 9. Well, 3 goes into 9. So that would be divisible by 3, but 9 is divisible by 9, so I can pull out a 9. If it were 27, 36, whatever, those would be divisible by 9. So 9 goes into 171 19 times, but the square root of 9 is 3, and 19 doesn't have any numbers to break it down. And even if this was like a 6, which is a 2 times a 3, if there's no pairs, it just gets multiplied together and sits back inside. That would be your final answer. Okay. Questions on any of that? Okay. Let's talk about congruent figures. This was the last page. We need to take roll. Okay. So if you're just joining us, we're going over Monday's notes, which is in Canvas. It's assignment number 18 to copy into your notes before class. Hopefully you did that. That's going to start being a requirement if you're not able to attend. So congruent figures. Anything can have a congruent figure, like a hexagon, octagon, but we're going to be dealing a lot more with the triangles. And if I'm told that triangle ABC is congruent to triangle DEF, there are 6 things that we know to be true. We know that 3 of the sides are going to be congruent and 3 of the angles are going to be congruent. And for us to know which one, we simply have to look at the letters. So the first letter in each set is going to be congruent. Those are the angles. The second letters in each set will be congruent. And the third letters in each set will be congruent. So angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. Not hard. Okay, the sides represented by 2 letters. So AB is a side, just like DE is a side. So AB is congruent to DE. BC, the last 2 letters, be congruent to the last 2 letters over here. So BC is congruent to EF. And then AC, the first and last letters, is congruent to the first and last letters, DF. We can also rearrange the letters, but if we do that, we need to be consistent. So let's say I wrote them backwards. Okay. Not backwards as in wrong, but just backwards as in I can do that. So I would call it angle CBA, or triangle CBA. The other one would have to be triangle FED. Notice I wrote it backwards also. If I called it triangle BCA, okay, the second and third and then the first, I'd have to have the second, third, and then the first right here. BCA is congruent to triangle EFD. But when you get to something like this question, is it okay to write triangle ACB is congruent to triangle EFD? Well, if you notice, those don't match. ACB, I took the middle one out and put it on the end. This one, I'd have to take the middle one out and put it on the end. So that would be DFE, and that's not DFE. So that answer is no, those are not congruent. So then we drew this picture, and I had 4 questions. Okay, so here we have 2 triangles joined by the middle, and we want to know triangle EFO would be congruent to what? Now, keep in mind, my drawings will never look the way they're supposed to. They're never going to be drawn to scale, and just because it looks like a right angle does not mean it is, unless I put the box. We can assume nothing in geometry. Okay, so here, EFO. So E starts way out here, F goes in toward the middle line, and then O is where they connect. So that would be my triangle, EFO. So what does it look like on the other side? Well, starting way out here would be H, going toward the center line would be G, and then down to O. So we'd have triangle HGO. And then we don't even need to look at that picture anymore because I have all my information right here. So I know that angle F is congruent to angle G. Side EF is congruent to side HG. And side FO is congruent to GO. Now here's what we really come up with all of this. How do I know that angle E would be congruent to angle H. If we were in a classroom setting, we'd be spending a lot more time developing this whole idea, but it's when or after I establish that the two triangles are congruent, because I know that all the parts are congruent. Okay, because here's the reason: corresponding parts of congruent triangles are congruent. Now we can write that shorter as this right here. Corresponding parts of symbol, 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 symbol. Okay. Or we simply write CP, CTC, which means corresponding parts, congruent triangles are congruent. So on a quiz, if you're asked, why are they congruent? Now this is after I've established the triangles are congruent. I can say that any of the sides or any of the angles are congruent by reason of CPCTC. Done. Okay. Any questions on that?
No.
Okay. So let's jump into today's notes. (9/29). Nope, today's the 30th. Okay. I should just put week of anyway. Okay, so here we go. In order to determine if two triangles are congruent, it must meet certain requirements. Three of them to be exact. So we're going to be looking at triangles and then trying to decide, well, not trying, but we will decide if they are congruent or not. There are 5 ways to determine if triangles are congruent, and we're going to be looking at 3 of those this week. And then we'll look at the other 2 and review next week. So the 3 we're going to be looking at, it looks like an S, an S, and an S, an SAS, and an ASA. Now, if we're talking triangles and S and A need to stand for something, there's only 2 things that it could stand for. S is going to stand for side, and A is going to stand for angle. So S is equal to side, and A is equal to angle. So for this one, we would read side, side, side. This one would read side, angle, side. This one would read angle, side, angle. Also, we need to remember that we'll be using or use tick marks and arc marks to denote equal sides or angles. Other information that we need to remember, I really am getting tired of saying this, but if we were in a classroom setting, okay, we would have done a little bit more in the proof area. Not a lot, but filling in, giving you reasons, but something that they assume that you remember. Remember, we don't really assume anything in geometry because we can prove it. We need other important information, abbreviated info. You must remember your vertical angles are congruent. That's a theorem that we had. And that any common side, or a side they have in common, will also be congruent. Okay. And we'll look at examples for both of those. So let's draw a kite with just one long stick in the middle. Those should have looked more equal, but it's okay. We're going to label our vertices A, B, C, and D. So when you're doing these problems, they actually have to give you information. You can add to that information based on what you're given. So the given information would be that side AB is congruent to BC, and side AD is congruent to side CD. Okay, well that's good. And the first thing we need to do is label. So step one, this is what I would usually do, S's and A's. Label my S's and my A's. So right now, the way it looks, this is a side. So I've got the side of this triangle is congruent to the side of that triangle. So we call that a pair. The side of this triangle is congruent to this side of that triangle. That's another congruent pair. Okay, but I only have 2 pieces of information and I need at least 3. So now we look to step 2. Label any vertical angles or common side as congruent. So remember that a vertical angle, and I'll put this back up here. Remember that the vertical angles make an X, where these angles right there are congruent. Okay. I don't have that in this picture, so there are no vertical angles. But a common side, let me explain what a common side is. It could be the common wall between your bedroom and another one. It could be if you've ever lived in an apartment or a condo, how you've got literally, it's 2 houses, but because I could separate it, but literally they're joined together. So this line would be the same as that line, and we mark it like so. Okay. So now I've got another side that's congruent to itself. If you remember that we use the property of reflexive to determine that something can equal itself. When you look in a mirror, you see yourself and hopefully nothing else. So you are congruent to yourself, and that's basically what that means. Okay, so now we look at the triangles left, meaning if I look at this triangle over here, it should have 3 of those letters in an order that will help me. So I have a side, it goes to a side, and it goes to another side. So that would be side, side, side. Let's look over here. Over here, I also have SSS for side, side, side. So they match. They must match. If they don't match, it's a no-go. It's not congruent. Okay, so this would be congruent by side, side, side. Now the problems in your assignment number 19 will ask you to label the triangles that are congruent. And there's many different ways you can do this. I usually start with the point that's furthest away, or the one that's like in the top left or top bottom, bottom left. So I would start with A, I could go B, I could go D. So triangle ABD. Well, if I started with that point way over here to the left, I'd have to start with the point way over here on the right. So I would go C, and since I went in the direction of B, I'd have to go in the direction of B, and then D. So this would be triangle CBD. And that would be it. However, you might not have saw or wrote those two particular triangles. We could have also written, and there's more than another one, there's like two more. I could have written triangle BAD, BAD. Notice all I did is rearrange or rotate those two letters. So it would be congruent to BCD. I just rotated those two letters also. So triangle BCD. Okay. Let's look at another one. Okay, so our triangles, we're going to draw the side and then a really long, and then drop it down the same amount. Okay, and then we're going to connect these two. Ooh, that was pretty good. And then we're going to label them A, B, C, D, E. Okay, so we have to label what we've been given. We're going to be told that side or segment EB is congruent to segment BC. And then segment AB is congruent to BD. Okay. So notice that for both of these, like EC, B is right in the middle. We know it's in the middle because it has two equal parts, one on each side. So we would be able to call B the midpoint of EC. We could also say, because these are equal, that B is the midpoint of AD. So I was just pointing that out. Okay, so let's label our A's and S's. There's an S, and there's an S, there's an S, and there's an S. But that's not enough information. That's only two pieces of information, not three. So does it have a common side that I can mark? What do you think?
No.
No, good. Common side would look like the one above. Okay. Does it have vertical angles?
Yeah, right?
Yes, it does. Makes an X right here. So I'm going to do that with a different color. So I can mark this vertical angle and this vertical angle. So now I have an A. Okay, that's my third piece of information. Now here's where it gets, where I have to take a minute to explain. If I cover up this triangle, the triangle on the left, we're going to look at the letters and the orders of the letters. And so if I started at the bottom S and I went to the left, I would skip an angle, I would skip a side, and I would skip another angle to get to my next S. I can't do that. It doesn't work. They must be consecutive, one after the other. So if it's going to be an S and then an A, it better be the very next A possible. So here's the side, the very next angle possible, and the very next side possible. Okay. So it wouldn't make as much sense to go to the left as it would to the right. Because I would go SAS. And then I would see, does that work on the other triangle? Okay. Well, yes, it does. I could start at the bottom, but this time I'm going to go left because it makes sense. So I would go SAS, or I could start at the top and go to the left. I'd go SAS. So that would actually be the reason for congruency. congruent by side, angle, side. And then we name the triangles. We have triangle ABE would be congruent to, what do you think?
Wouldn't it be DCB?
DBC.
Oh, okay, sorry.
Yeah, no, you're fine. So if I start way out here on the top corner, I start way down here on the bottom corner. So I start with D, triangle D. This one moved into B, so this one's going to move into B. And then it went out to E. This one's going to go out to C. Okay. And that's how that works. It's not meant to be super hard. Some of them are very difficult to see visually because they're like rotated and flipped. I'm like, and I have trouble with those, I have to admit. Okay. We could have also named it or EBA, triangle. EBA would be congruent to. Notice all I did was I put it in reverse. So this would be triangle CBD. Okay. And then I could have started with B and then went around. There's a lot of different ways to do it. Anybody still writing? Okay. So this one's going to be two triangles together. They're going to look kind of like a butterfly. So I'm going to draw an X, something like that, and then we'll connect them. And then we'll label A, B, C, D, E. And we're going to be given the information that angle E is congruent to angle D, and segment EB is congruent to segment BD. It is so much easier to work your problems when you have a picture. I require that you label your picture because I don't want just an answer, because I give you those answers to check. I haven't actually posted the answers yet, so I'm going to give you guys a few days to do it so that you can check your work. So if you don't have it printed out, that's fine. I don't require it. You can copy the pictures. Even just a quick sketch is fine, okay? You don't have to label all the points unless you want to, but you do need to label your pictures, whether it's vertical angles or common side, etc. Okay, so labeling what we do have, we have an angle and we have a side. We have a side and we have an angle. Okay, well, based on what we have, we've been using side, 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 or angle, side, angle. If I'm getting an angle and a side, I could either use the second one or I could use the third one. It depends on what information they give me next. If they give me that side AE is congruent to CD, then I would have side, angle, side. But we don't know that. But what do we know that's equal, that's not marked on my picture yet? Does it have
Wait,
a
what?
What's that?
I'm a little confused. Wait, what?
Okay, I was just gonna say, does it have a common side?
No.
No. Does it have vertical angles?
Yeah.
Yes.
Okay.
So that's what we're gonna mark. Okay. And then I write it down. So now I have an angle and an angle. I'm gonna notice that these are consecutive. An angle, the very next side, the very next angle. Angle, the very next side, the very next angle. So they match. The two triangles match independently. So this would be congruent by angle, side, angle. And then we'll name our triangle. So a triangle, I usually start with the tip top out here or the one furthest away. Just, I've gotten used to that and it makes it a little bit easier to be consistent. So I probably go A, move to the center, B, move out to the other edge, E. So triangle ABE would be congruent to, what would the other one be then?
CBD.
Good. Triangle CBD. Starting with the outer corner, moving into B, out to D. Okay. And then just another one that we could do. You don't have to do more than one. We could have called it BAE. It would be congruent to triangle BCD. Okay, so that would be an OR. So we're actually nearing the end of our notes, and then we're going to do a few of your assignment problems together. But let's look at what works and what doesn't work for as far as congruency in geometry. So what works and does not work? Well, this week we're talking about these three: side, angle, angle, and side, side, side. So those work. We've seen those in action. Next week, we're going to be talking about, so next week, angle, side, and HL, where HL is only for right triangles. You have a hypotenuse and a leg. Okay. So this is a yes. Yes, congruent. The no, the not congruent would be your SSA. There's another one too, but let's look at this one for a minute. This means side, side, angle. And if you spell it backwards, you get a donkey or you're behind. Okay, this does not work. And I usually tell kids, no donkeys in geometry. So that they remember if they come up to an SSA, that it doesn't work. No donkeys in geometry. The other one that does not work is AAA, AAA. Angle, angle, angle only ensures that it's the same shape. So let me give you an example. If I have a golf ball and a basketball, they're both a round sphere, but there's nothing that guarantees me there's the same exact size. So somewhere in there, we have to have an S, okay, whether it's in the middle or on the edge. Okay, so that doesn't work. So these two do not work. And remember, no donkeys in geometry. So that's the end of the actual notes. If you could bring up assignment number 19, we're going to do 6 of those together. You can write them on a separate piece of paper where you're going to do your other work. It's up to you. But we're going to go ahead and get a good start on it because we're going to do 6 of them together. Because it really does help if you can see it in action. Okay, so number 15. It's okay to sketch these. I suppose you could name the triangle from the picture on your computer. But at least draw the triangles, okay? So let's label what we have. We have an S, we have an A, and we have an S. Okay, well, I have a reason for that. Now over here, I've got an S, and an A. And when we stop to look at those, it's like well, they don't quite match. You know, it's like, can we do that? This one's a side angle side, and this one's a side angle. Okay. First of all, we can't do a side angle because there's no donkeys in geometry. However, if you're going to prove triangles are congruent, they must match. These must match, and they do not. So this is not congruent or not enough information. If we knew that H was congruent to angle B, then we'd be fine. Let's look at number 19. So labeling what we have an angle here and an angle there. That doesn't give me very much to go on. I need 3 pieces of information and they only gave me 1. Do they have vertical angles or a common side that I can label?
Don't they have a common side?
They do, they have a common side. Okay, so I can label this common side congruent to itself. Now I have a side. But that's still only 2 pieces of information. I know nothing else about the other sides or other angles. So because they only give us 2 pieces of information, we would write not enough information and be done. Let's look at 21. So labeling, I've got a side, a side, a side, and a side. Well, that only gives me 2 pieces of information, and there's no shared side, and there's no vertical angles. So there's only 2 pieces of information, and that's not enough. So we'd write not enough information. Is this making sense?
Yeah.
Okay, how about the others? Anything that I can clarify so far?
No.
Okay. We have a quiet group. Okay, so let's look at 23. Labeling what I've got an angle, I've got this side, and I've got that side. Well, we have 2 pieces of information. Is there a third that I can label?
The middle one.
The middle one, because it's a common side. Awesome. So now we have an S. So if I'm looking at the left or upper triangle, I would have side, angle, side. Looking at the lower or right triangle, I would have side, angle, side. So they match, and they're a reason that we can use. So these would be congruent by side, angle, side. And then we get to label our triangles. So triangle ABD would be congruent to CBD. I need to be done. Okay, 2 more and I'll stop talking. 22. So we have an angle here, an angle there, an angle there, and an angle there. Okay. So I've got a pair of angles, that's 1 piece of information, and another pair of angles, that's 2 pieces of information. What else can I label?
The A and C and E and C are like the same, right? Like you would put the line in the S or whatever it's called.
Well, what kind of angles do I have when I have an X? Can somebody help her? Teamwork. It's not a shared side, but what kind of angles do we have? If you look back in your notes, anytime it makes an X,
Reflect.
right above that. The two angles that we call the two angles when they make an X and they're right across from each other. Okay, guys, help Alyssa. She doesn't need to do it all by herself. Josh, Ace, what do you guys think?
I'm looking right now.
Sorry, I couldn't hear you. What are the angles called?
An X is vertical, right?
They are vertical. Awesome, thank you, Ace. Okay, so I can mark vertical angles. I can mark the vertical angles across from each other. And now I have another set of angles. So an angle here and an angle there. So now I've got three pieces of information. I've got three pairs of angles. So I have angle, angle, angle. But we just talked about angle, angle, angle is not something we can use for congruency. It's actually called similarity. And that's not what we're proving. So this does not work. So this would be a no, or not enough information. Because if we knew that one of these sides were equal to its other corresponding side, then we could say it was congruent, but it's not. And then this one, 24, over here, just marking our sides. First of all, there's no vertical angles, there's no common side. Okay, so we have a side, and a side. And over here we have a side, and a side. So what reason do you think we're going to use for this one?
SSS.
SSS, nice. So congruent by SSS. Labeling the triangles, we can just go left to right. So I go triangle ABC. Oops. Yeah. Triangle ABC is congruent to, well, if I started over here and start here, so DFE.
Yeah.
DFE. Okay. Any questions on that? Okay. Let's see.